So for this assignment, I am continuing with the 3 month summer community garden build project. In the last assignment, we built a Gantt chart, which is a timeline, and so now we are building a PERT chart, which is a logic and risk diagram. And so a key part of the PERT technique is the 3 point estimate. So instead of just one guess for how long a task will take, I gave an optimistic, most likely, and pessimistic time for all 21 tasks. And so from that, I used the PERT formula to calculate a risk-adjusted expected duration for each task. Um, this is really this is this is important for a project like this one, like ours, because securing permits could take 10 days or even 30. Um, PERT helps us build a plan that accounts for that uncertainty, right? And so here, as you can see, is a PERT chart I created. So, quick background. I actually built this using Mermaid, which is a code-based diagramming tool. And so this was perfect because it let me define all the dependencies and even style the critical path right in my code, which you can see rendered here. And so each box is a task from our project, and the arrows show the dependencies, you know, um, which are essentially what needs to happen first. So let's see here. Yeah, so yeah, this visualization is, I'd say, it's the real perk or benefit of PERT. You can immediately see the project's logic. For example, right here at 1.3.1, assemble uh, raised beds, right? It can't start until both mark out layout and order bulk materials are actually finished. So this kind of complex, like many to one dependency, is what PERT is designed to show. And yeah, it also makes parallel tasks really clear. You can see in the construction phase, we have 5 different tasks, all branching off from the site prep. So which can all be worked on at the same time. Um, Also, you know, uh, so I'd say the most important feature of the PERT chart is finding the critical path. Yeah, which I've highlighted in red. Um, the critical path is the longest sequence of dependent tasks that determines the project's total duration. And in this project, the path runs from forming the committee through the big secure approval task, through all the site prep, the main bed assembly, plot registration, and all the way to the grand opening. So I calculated the total expected duration for the path to be about 66.8 days. And so this is the key insight, right? That if any task on this specific path is delayed by even just one day, the entire project's end date will be delayed. So, um, yeah, yeah, it will be delayed. And so, as a project manager, this chart tells me exactly where to focus my attention and my risk management efforts. Yeah, how does this compare to the Gantt chart from the last assignment? The Gantt chart is much better by for visualizing the schedule. It's a communication tool. It's easy to open in a weekly meeting and see what the team should be working on in week three, for example. The PERT chart is terrible for that. So you can't tell what day it is, and it's not meant to, even to be honest. It's a just planning and analysis tool. And so its job is to show logic and dependencies. And so you simply cannot see the critical path or complex relationships this clearly on a Gantt chart. Personally, I find the Gantt chart is more intuitive for tracking day-to-day progress, but the PERT chart was far more valuable for the initial planning and for understanding the project's complex interconnected structure. So really, both tools are essential. The PERT chart helps you. The PERT chart helps you analyze the logic and risk to build a solid plan. While the Gantt chart, it helps you put that plan on a calendar and execute it with your team. And so they work together perfectly.